I have also been automation engineer and QA consultant for big companies. I have designed this course for anyone who wants to start his career as a quality assurance engineer, which I believe is a great way to start your IT career. In this course, we will go very basic and you will learn step by step what is the software development life cycle, what is a software Scrum team and what are the responsibilities of each member, what is agile methodology, what are the different kinds of testing, what is a bug, what is a test case and how to create test cases, what is the difference between white box and black box testing, what is cross-browser testing, what is user acceptance testing and who is doing it, what is Jira and why we are using it, what is regression testing and exploratory testing, what is the difference between volume and load testing, when you should move from manual to automation testing. In the later sessions, I will show you real-life interview questions and I will prepare you for your first QA job interview. And I will also show you 3 websites from which you can make money with testing. If you're someone who wants to become quality assurance engineer or someone who wants to enter the IT field and have goals for a better life, this course is for you. My main goal for this course is to teach you how to start your first job as a QA engineer. We will go very basic and step by step, and by the end of this course you will be able to apply for jobs for a junior manual QA engineer. I thank you for your time and I look forward to see you in the first lesson. Hello and welcome to my course on how to become quality assurance engineer for beginners. In this first video, I want to welcome you to the course and thank you so much for being here. I appreciate you as my student and I want to ask you for your review for this course. It's really important for me to have your feedback to improve my courses. I'm always improving on my courses and trying to make them the best possible for you. So if you have any suggestions and feedback, please leave me a comment, send me a message, tell me what you like and what you didn't like in the course, and very important for me, please leave me your review. Thank you so much one more time for being here. Now let's not waste any more time and start with the first lesson. Hello everyone and welcome to the course once again. I want to start this first lesson by explaining what is the SDLC or Software Development Lifecycle. And the software development lifecycle is a systematic process for building software that ensures the quality and correctness of the software built. SDLC process aims to produce high quality software which meets customer expectations. The software development should be complete in the predefined time frame and cost. And basically, the software development life cycle is just a process for developing software. And you may be asked this question if you're going to interview for a junior developer or QA engineer. And basically, the whole process starts with requirements. And if you're a customer, for example, and you want a website, you're going to this company which is creating websites and you're telling them that you want to create, for example, this website like Udemy. You want to be able to upload courses and people to watch them and to leave reviews and comments and to be able to purchase from your website. All of this is the requirements. So the customer, the client comes with his requirements. This is the first phase of the software development lifecycle. After you have all the requirements from the client and you know what exactly you should be building as a software product, after that the design phase is coming into place. And this is the phase where the UA or the UX designer and the front-end developers are creating the design or how the website or the platform is going to look like. they're building the design and they're giving it to the client. The client is giving his feedback, and this process may take a while until the client is satisfied with the final version of the design. And after that, after we have all the requirements and the design is created and the client have approved the design, after that the next phase is the implementation. This is where the developers and the programmers are starting to code the actual software. After the coding, after some functionality is being developed and is ready for testing, here it comes the next phase. After the implementation of the software has been done, it comes time for us as a QA engineers or software testers to test the software or test the functionality that the developers have been creating. Usually during this phase we find a lot of bugs or defects, some things that are not the same with the requirements that the client have given us in the beginning. And in the testing phase we may give something back to the developers, back to the implementation phase. When it's ready, it's coming back to testing. If it's not okay, we bring it back to implementation. When it's ready, it's coming back to testing. And when the QA engineers or testers are saying that everything is okay and this functionality, this product is ready to be delivered to the client, then we give this product to the client when the product is actually created and tested, and it is what the client have been asked for in the beginning. Then we deliver this product to the client, and after that comes the final phase, which is evolution or maintenance. Basically, after this phase we are just making sure that there are no problems and the client can use his product. And I want to show you another picture which is basically the same thing but with other graph. I want to make sure that you understand this. It's very important because this is the foundation. This is how all the big companies, the big outsourcing IT companies are working, and you need to know how everything is working, how everything is connected, because we are not working alone. We are working in a team always, and you need to collaborate with everybody and to be on the same page so we can deliver the best product possible for the client. And again, the first phase is the requirements. The client is coming to us and is giving all the requirements, and is giving us all the requirements about the product. After that, the design phase it's starting, and the designers are making the design for the client, and after he approves the design, we're starting to create the actual project. This is the implementation phase or the coding of the project. This phase is done by the developers. After that, we're coming to the testing. This is our job as a QA engineers. We are testing the product, and if everything is okay, and after the product has been tested and it's approved by us, we are deploying the product to production, and basically the client can use the product. And the final phase is maintenance. We are making sure that everything is working as expected for the next months and the client can use his software. This is basically it. This is the software development life cycle, and you need to know this. You need to be aware that you're going to work with other people, and who is going to do exactly which phase of the development. The final goal is to create a software which is in line with the requirements that we had in the beginning from the client, and everybody is going to be happy in the end. So if somebody is asking you this in the interview, now you know what is the software development life cycle. I hope that was useful. Now let's continue with the next lesson. Hello and welcome to this video. Now we are going to talk about Agile. So what is Agile? If you look for agile software development into Wikipedia, you're going to find something like this, and I'm just going to read this for you, and after that I'm going to explain it with my words. Agile software development is an approach to software development under which requirements and solutions evolve through the collaborative effort of self-organizing and cross-functional teams and their customers and users. It advocates adaptive planning, evolutionary development, early delivery, and continual improvement, and it encourages rapid and flexible response to change. The term agile was popularized in this context. The term agile was popularized in this context by the Manifesto for Agile Software Development. The values and principles exposed in this manifesto were derived from the underpin a broad range of software development frameworks, including Scrum and Kanban. So, to explain this in a shorter way with my own words, I would say Agile is a set of principles and values, and the aim of Agile is to create a better software. The aim of Agile is to be ready for changes and to update things, to get feedback from the client as soon as we are ready to give something to the client, so he can give his feedback right away and we can improve things. And this is the whole concept of Agile. The whole concept is to be agile, to be quick, to improve things, to become better and better every day, to deliver software fast, so we can get the initial feedback from the client. And basically that's the principles and values in order to create better software and to deliver faster software. Probably you have heard of Scrum and Kanban. These are the two most popular frameworks of Agile, and I have been working in Scrum and Kanban teams, and I know the benefits of both of them. And the main difference is that in Scrum you're working into sprints. So basically you have a user story, or we may say functionality that the team is going to create, and we are estimating this functionality with story points. And for example, our sprint is going to be 2 weeks, which means that we need to create this functionality for 2 weeks. You have a time frame for which you need to create this, and you're working into sprints, and each sprint you're delivering something to the client. A small portion of the software is being delivered every week or every 2 weeks, depending on the length of the sprint. In Kanban, you don't have a time frame to deliver something to the client. You're constantly delivering, so you don't have sprints like 1 week or 2 weeks. Everybody's taking something from the Kanban board as soon as he is ready working with something else. So if you're a developer and you have a task, you finish your task. As soon as you're ready with your task, you're going to the board and you are checking what is the next thing with the highest priority, and you're taking that and start working on that. So there is no time frame. For example, we want to deliver this specific thing for 1 week. You're working on something, and when it's ready, you're starting the next thing, which is in line. And this is basically the difference. I like Scrum better because you know each day what exactly you're doing and how much time you have for it, but both of them are great ways for developing software. And also the base of Agile and the foundation of this methodology to be flexible and to improve yourself and your team every single day comes with some meetings and some things that have been proven to work well. And one of these things is a daily meeting, daily stand-up meeting with your whole team. For example, what we were doing in my team, every morning 10 o'clock in the morning, we are having a daily stand-up meeting, and everybody's telling and everybody is explaining just for 1 or 2 minutes what is he working on, if he have any problems, have any blockers, if he needs help with somebody else, and what he did yesterday, what is he doing today, and what he's going to do tomorrow. And the point of this is to have everybody on the same line, so everybody knows his colleague, what is his colleague working on, and when something is going to be ready for testing, for example. So daily stand-up meetings are really important and are really helping with developing software and having a better communication with your team. Another thing is if you're working in on Scrum, Agile Scrum methodology or principle, in the end of your sprints or in the end of your week or 2 weeks, you have a refinement meeting where you are talking with your team basically during these 1 or 2 weeks, during this sprint, what have been working good, what have been working well, and you want to continue doing that, what was not working well, what you can improve, and if you have any suggestions for the next week, for the next sprint, and how you can make the process better. This is Agile, basically, in 2 words, making everything better every single day, and improving and delivering faster software, getting feedback, and just constantly delivering better and better software. And yeah, that is Agile. Basically, you have daily stand-up meetings when you're working in Agile environment. In the beginning, when you're starting to work on new functionality, you have a planning meeting where you're creating tasks for everybody, so everybody knows what exactly he's going to do this day, tomorrow, the day after tomorrow, how much time he has for this task, for the other task. And basically for the next 1 week or 2, you have a plan, a written plan that you need to follow and you need to execute. And this is really helpful because you're not wondering what exactly I'm going to do, from where should I start. You have a planning meeting where you're talking about these things and making sure that everybody's on the same page. And in the end of the sprint, you have a refinement meeting when you're saying what went well, what went bad, and how to improve the process for the next sprint. Basically, that is Agile, a set of principles and methodologies to deliver better software and to deliver faster, and to get feedback from the client in order to improve the software. I hope that was useful. Now let's continue with the next lesson. Hello everyone and welcome to this lesson. Now we are going to talk about what is a Scrum team and what is the role of each member in the team. And the Scrum team is a collection of individuals, usually between 5 and 9 members. Could be 10, 11, but between 5 and 9 is the typical Scrum team, working together to deliver the required product. And when we are talking about the Scrum team, we are talking about the Scrum Master, which manages the Scrum process. This may be the project manager. He may do this work, or you may have a project manager and a Scrum Master. Also in the Scrum team there is developers, backend and front-end developers, QA engineers, so this can be manual testing or automation testing or both of them. You may have business analysts. This is the person which is taking all the requirements and basically making all the documentation and making sure that everybody understands the business point of view of the product. You may have architect, which is usually this is a really senior developer, which knows everything about all the technical things and the technical stack which is required for the product. For example, if the client comes only with his idea and he doesn't know which languages are good for this product, and he just have an idea. The architect is the person who is telling, for example, we are going to use Java for this, or C#. It's going to be suitable for this kind of project, and he is developing the framework and all the necessary technical things in the product. The product owner is part of the client's team. This is a person who is responsible for the delivering of the product. So the product owner is responsible for looking after the product for extended period of time and is accountable for achieving product success. So this is the person who is constantly in touch with the team, with the stakeholders, and is updating everybody on how the product has been developed. And I know that this graph may see a little bit of too much for you in the beginning, so I just want to I have created this file for you just to have it as something a little bit simpler, so you may say. So the Scrum team, the team that is developing the product, consists usually of a project manager, the person who is managing the project, who is creating all the tasks, who is creating the user stories, who is managing mainly everything in the product, who is contacting the client side, the business owner, the product owner, and basically he's the link between the Scrum team and the client. Scrum Master, this role in my previous team was done from the project manager, but usually this is the person who is making sure that everybody have everything needed in order to do their job, and there are no problems into the development in the product. The developers, this consists of front-end and back-end developers. Next is QA engineers. This can be manual or automation testing. Designers, these are the people that are making the design of the project. This is this is after the requirements phase. The business analyst is the person who is making sure that everybody has the right documentation, the right requirements, and everybody understands the business logic of the product. And from the client side, there is a product owner, basically a person who is constantly in touch with the team, with the Scrum team, and is asking how is everything going. You're making demonstrations to this person and showing him what is the progress, and he's basically the person who is responsible for the product from the client side. And we as a QA engineers, we are standing here, and our job is to test the software to make sure that everything is in line with the requirements, and we are part of the Scrum team. I hope that was useful. This is really essential before we start talking about testing and quality assurance. You need to have a general idea and overview of how everything is working, what is the process of developing software, and after that we are going to go deep into the quality assurance and to testing profession. But this is really important to have an overview of how everything is working, because we are not working alone. We are part of the Scrum team, and basically this will help you if you know exactly what role and what part of the team everybody is doing, and if you collaborate with all of your colleagues, it will be much easier for you to do your job. So I hope that was useful. Now let's continue with the next lesson. Hello there, and welcome to this tutorial. Today we are going to talk about the different types of testing, and I want to give you the basics here of the different types of testing, and we are not going to dive deep into each one. We are going to into the later sessions we are going to learn about the most important ones. But as a beginner, I want you to just to know the basics and to hear about different types of testing, because when you go to an interview and when somebody is asking you, have you ever heard of integration testing, for example, you can say yes, this is a part of a functional testing and is done by this person, just to have a general overview for the types of testing. And the foundation thing that I want you to understand is that there is two types of testing in general. Functional testing and non-functional testing. Functional testing is everything related to the functionality. Is this functionality working or not? The non-functional testing is related to not directly to the is the functionality working or not, but is the functionality working fast enough? Is it a little bit slow? This is the performance part. This is the non-functional testing. So when you're testing the functionality and looking for defects, and you're testing if the functionality is working or not, this is functional testing. When you're testing the functionality for being too slow and for example not working as expected when you load the website with 2000 users, this is non-functional testing. I want you to understand the difference when somebody is asking you, just to know this. And functional testing includes unit testing, which is done by the developers, not by us, by QA engineers. So, and we can say that unit testing is testing individual components. Developers are writing unit tests to test individual components to see if they are working as expected. And integration testing is if you link all of these units together, are they working as expected as a whole? For example, you have 10 small things that are working fine. The unit tests are covering these 10 small things. One unit test is covering one thing, the second unit test is covering the second thing, and these 10 things are working as expected as a different units. And integration testing is to check when these 10 units come together, are they working as expected when they're integrated as a unit. These are integration tests. Also system testing, sanity testing, smoke testing, interface testing, regression testing, and acceptance testing. These are the functional testing. Again, we're going to talk more about the most important ones in the later sessions. I just want you to give a general overview here. Non-functional testing is a performance testing, load testing, stress testing, volume testing, security testing, compatibility testing, recovery testing, usability testing, and compliance testing. There are many types of testing, and even more than what we have here, a lot more than that. But you don't need to know everything. Especially in the beginning, you're not expected to do everything. For example, when you're applying for a junior QA engineer, you're not expected to do performance testing. Usually performance testing and security testing, they're completely different jobs for completely different types of people. If you're a QA engineer, usually you're going to do as a general QA engineer, you're going to do test cases, you're going to execute them manually, you're going to do test plan, test execution. After that you're going to decide which test case you're going to automate, and this is the general QA engineer role. To make sure that the software is working as expected, you need to know all the requirements, and basically you're responsible for the quality of the product. but the performance testing is a complete different thing, and people are doing this as another job sometimes. For example, if you're using JMeter to see also the security testing, or white hat hackers, these are also people that can be defined in a different category. So my main point here is that you don't need to know everything in the beginning. I just want to give you an overview. I want you to know what are these roles and what are these different types of testing doing. And you need to know that in the beginning, when you apply for a job, you're not expected to be responsible for each of these types of testing. I want you to just to hear about them, because if somebody is asking you, now you know about these kind of things. It's not something completely new to you. And when you start working and when you're in a company, in a project, you will have a better understanding about all of these things. Now I want you just to know that generally there are two types of testing, functional and non-functional, and just to hear about all of these things. In the later sessions we are going to talk about some of these kinds of testing. Now let's continue with the next lesson. Hello everyone, and welcome to this lesson. Now I'm going to explain to you what is a bug, a software bug. A software bug is an error, flaw, failure, or fault in a computer program or system that causes it to produce an incorrect or unexpected result, or to behave in unintended ways. The process of finding and fixing bugs is termed as debugging. And to say it with my own words, because I copied this from Wikipedia or somewhere on the internet, to be honest, to say it with my own words, a bug is just something that is not working as expected. It can be anything. If, for example, when I'm expecting this Notepad++ to open when I click 2 times, if it's not opening, this is a bug. Everything that is not working as expected is a bug. It can be a huge thing, something that causes millions of dollars, or something that causes even human lives. If you are working in a health company, and which is, for example, developing some medical things, this is really important. Or if we're working for a car company, and we're working on a functionality where the software is for example, self-driving car, and there is a bug in this software that means that this car can crash and humans can die. So this is really important for us to do our job and to make sure there are no bugs, no major bugs. Or if you're working in an aircraft company, the pressure is really huge, because you know that if there is a bug, something that is not working right into the aircraft, into the plane, also people can be damaged. So this is really important. So it depends on the type of project that you're working, rather than the bug can be really a big type of severity, or it can be something that is just going to cost money to the client. So just to summarize, a bug is something that is not working as expected, as simple as that. If you know a system, you know the requirements, how something should be working, you do your task, and if the end result is something else and it's not working as expected, this is a bug. And I want to quickly show you this article about the history's most expensive software bugs, just to show you what is the impact that can be done by finding bugs and by doing our job and making sure that the software is have the necessary quality and there are no major bugs. For example, this Mariner 1 spacecraft bug that cost $18.5 million. So basically there is some marine spacecraft that okay, let's read this from the beginning. At 18.5 million, the Mariner 1 spacecraft is the least expensive bug on our historical list. In 1962, a programmer incorrectly transcribed a crucial formula when writing the spacecraft source code. The lack of a single superscript bar caused the rocket to overcompensate its trajectory as it launched, veering dangerously off its intended flight path. So there was a bug in a rocket. That's a pretty big deal, and it cost the company $18.5 million. And this is the least expensive bug into this list. If we go to the more expensive ones, oh my god, $96 million, $475 million, and the most expensive one was $500 billion. So the Y2K bug might be the most expensive bug since the development of computers. Yet many don't stop and think of its cost because the resulting large-scale computer disasters never happened. So that was a bug across multiple types of software that reduced the calendar years in data sets to be stored as the last 2 digits of the year to save space. In other words, a computer would read 00 at the end of the date as 1900, not 2000. That's a pretty big issue. The issue could have caused major bugs in government, financial, scientific software, and more had it not been addressed. So that is a huge bug costing a lot of money to the governments and a lot of people. But this is just something that causes money. This is the better type of bugs. The worst part is when, as I said, if you're working into the health industry, when it comes to developing medications for people, or if you're working for as I said, a car company, something that is responsible for people's lives, or airplanes or something like that. It's really crucial to find these bugs and to make sure that the software is going to work as expected, because the worst thing that can happen is to somebody to get hurt. We don't want that, and if you're working on a project and on a software that is going to be responsible for people's lives, it's a pretty big deal, and you want to find these bugs as soon as possible. And just wanted to tell you how big of an impact this can have. So find your bugs. I'll see you in the next lesson. Hello everyone. Today I'm going to explain what is a test case. First, I'm going to read this description right here, and after that I'm going to explain it with my own words. So a test case is a set of conditions and variables under which a tester will determine whether a system under test satisfies requirements or works correctly. The process of developing test cases can also help find problems in the requirements or design of an application. So basically a test case is a set of steps that you execute in order to verify that the functionality is working or not. And when we start writing test cases in the next session, you will get this even better, but I want to show you this example of a test case. So this is a test case template, just to get familiar with this terminology. After you start writing them and you write a lot of test cases, you'll just become better and better, and this will become really easy for you. Now if this is really confusing for you in the beginning, this is normal. Don't get frustrated. You'll learn with this course goes with the later sessions, and I'm sure that you'll become better and better every day, and you can start your work as a QA engineer in no time, I am sure. So a test case is a conditions, just steps that you execute in order to verify that the functionality is working or not. And let's see this test case template. All of these steps are not necessary. Everybody has a different style of writing test cases. I will show you mine in the next video, but let's just check this one. There can be a test suite ID, test case ID. This is not necessary, I'm telling you once again. Test case summary, okay, this is the basically no, this is not the name of the test case. Okay, there is a related requirement, prerequisites. This is important. Any prerequisites or preconditions that must be fulfilled prior to executing the test. So some necessary things that need to be executed before the test. For example, if you need a specific version of a browser, you're going to say it here into the prerequisites. Test procedure, step-by-step procedure to execute the test. Okay, these are the test steps. Test data, any links, any usernames and passwords, for example, that you're going to need for the test case. The expected result, something really important, the expected result of the test at the end, the actual result of the test, and the status of the test, really important. This can be pass or fail, depending of the end result of the test. You may have created by, you put your name here, date of creation, executed by, so this test can be executed from another person, date of execution, and test environment. Okay, this is the example of the test case. So test case summary, to verify that clicking the generate coin button generates coins. This is basically the name of the test case. Okay, prerequisites, user is authorized. So before starting to execute the test case, first you need to authorize with a user, and also coin balance is available. You need to make sure that these two things are done before executing the test. That means the prerequisites. After that comes the test procedure. Basically, this is the test steps. The first thing, select the coin denomination in the denomination field. I don't know what is this, but this is just the first step of the test case, apparently. Second step, enter the number of coins in the quantity field. And third step, click generate coin. This is a test data, so we are going to enter these things, quantities, okay. And after that we have expected result. So the thing that should happen is coin of the specified denomination should be produced if the specified quantity is valid, okay. And a message, please enter a valid quantity between 1 and 10, should be displayed if the specified quantity is invalid. So this is the expected result, what should happen at the end of the test case. The actual result is something that actually happened. This can be the same with the expected result, which means that the test will pass, and the actual result can be different from the expected result, which means that the test will fail. Okay, here we have in the actual result, if the specified quantity is valid, the result is as expected. Okay, I just say that. And the status, we have a fail or pass. Remarks, this is a simple test case. Okay, created by John Doe, date of creation, executed by Jane Doe, and date of execution. This can be different date from the creation date, and the person executing the test could be different than the person creating the test. It's really important to write really understandable and simple test cases, because most of the times other people are going to look at your test cases after some time have passed, for example, you're working for this project and you write the test cases and you execute them, and 2 years after that, for example, you're not working on this project anymore and another person is coming and he wants to read all the documentation to get familiar with the project. He's most probably going to read your test cases, so make sure that you write them really simple, really clear, really systematic, so when another person is looking at them, he can understand what happens. Okay, let's see what we have here. Writing good test cases. As far as possible, write test cases in such a way that you test only one thing at a time. This is really important to make them simple. Okay, do not overlap or complicate test cases. Attempt to make your test cases atomic. So basically what I said just now, make them as simple as possible. Ensure that all positive scenarios and negative scenarios are covered. Of course, you make sure that you're covering everything. Language, so write in simple and easy to understand language. Yep. Use active voice instead of passive voice. Do this, do that. Okay. Use exact and consistent names, form, fields, etc. Basically be specific, and so another person can know exactly what he should do when executing your test case. And characteristics of a good test case: accurate, exact, the purpose, economical, no unnecessary steps or words, traceable, capable of being traced to requirements, yes, very important, repeatable, can be used to perform the test over and over again, and reusable, can be reused if necessary. So to summarize, a test case is just verification steps that you need to execute, and in the end of the test case, after you execute the steps, you have end result, and if this result is what you expected, the test is passing. If the end result is not what you were expecting from the requirements, then the test is failing. So a test case is just steps that you execute in order to see if something is working as expected. Now in the next step I'm going to show you how I'm writing the tests, so let's continue with the next lesson. Hello everyone and welcome to this tutorial. Now I'm going to teach you how to write a test case. This is really important for your career as a QA engineer. You're going to write a lot of test cases and you're going to execute a lot of test cases, and this is the first step of becoming a QA engineer. It's something that if you develop this habit of creating really simple test cases, your work is going to be much easier and much maintainable in the future. So usually you're going to write your test cases into a project management system like Jira, for example, but I want to teach you how to write your test cases from scratch in Notepad, for example, because if you learn to do this, after that you will be able to write them anywhere, and it will be much easier for you when you have a template, when you get to this system and you have first step, second step, third step, and everything is explained really easy. It will be much easier for you to create a test case if you learn how to create test cases now from scratch into Notepad. Later on it will be much easier for you. So we will create our test case absolutely from scratch here in Notepad, and for example, let's say that we want to test a login page. Let's go to a website, IMDb, for example. IMDb, I think you know this website. It's a huge marketplace for movies, and let's say we want to test this login button. So sign in, after that sign in with IMDb, and we want to test this login for this sign in form. Okay, so Let's go back into the dashboard page and let's open our notepad. The first thing that I want to write is the name of the test case. So we need to have in our mind an overview what we are going to test and what will be the expected result. So I want to test now that with invalid credentials I will not be able to log in into the system. So I want to test that if I write here some fake email which is obviously not right, and some password which is not correct, I will not be able to log in. So let's create a test case for that. So the name of the test case will be user is not able to log in with invalid credentials. This will be my test case name. Usually you will have this written into the project management system, but I will write here test case name just for you to get familiar with that. After that we will have some prerequisites. For example, this is just an example here. Need to have Google Chrome latest version, for example. Next thing, I will have test data, which will be username and password that I'm going to use for this test case. So username will be pewpew@gmail.com and the password will be my awesome password. After that I will have test steps. Okay, here I will have my first step, which is go to imdb.com. No, the first step will be open Google Chrome. The second step will be go to www.imdb.com. Step 3 will be, so I'm here now. The step 3 will be click on sign in. So click on the sign in button. The fourth step will be, okay, so I want to make sure that you're following me. The first step, okay, let's do it from the beginning. First step, open Google Chrome. Okay, I'm opening the Chrome. Second step is go to imdb.com. Okay, I'm going to imdb.com. Third step is click on the sign in button. Okay, I'm clicking here. The next step will be click on sign in with IMDb. Okay, I click here. So click on sign in. What was the button? Sign in with IMDb. Okay, with IMDb. Okay, after I click here, the next step is to write the email. So this actually here will be email. So the next step will be to write this email here. So the next step will be enter this email into the email field. Okay, step number 6 will be enter the password, enter my awesome password into the password field, and the next step will be click sign in. Click sign in. Okay, and after that we should verify that the user is not logging with these invalid credentials. So after that we will have expected result, and after that we will have actual result. Okay, so the expected result should be you are not able to log in the system, error message is displayed, error message for wrong, that's all, error message is displayed, actual result. Okay, the actual result, so I am not able to log in, so the actual result is I am not able to log in the system, error message is displayed, or you can say user. So user is not able to log into the system, and here user is not able to log into the system. So let's go through this test case one more time. I'm closing the tab, and this is the whole test case. Usually I'm putting images here into the expected result and to the actual result, so it's even more clear and understandable for the person who is reading the test case. So let's execute this test case right now. Usually from the test case name you should already know what is going to happen with this test. You should write the name of the test case in a way that when somebody is reading the name of the test case, he knows what is this test case about and what he's going to test. So when I read user is not able to log in with invalid credentials, I immediately know that I'm going to test a logging functionality, and I'm going to test that with invalid credentials I should not be able to log in. So after the test case name I have prerequisites, need to have Google Chrome latest version. Okay, I have this before executing the test case. I have the test data here that I'm going to need for the test case, and after that I'm starting to execute the test steps. The first step is to open Google Chrome. Okay, I'm opening the Google Chrome. Second step, step number 2, is go to imdb.com. Okay, I'm putting this into the URL. Okay, step number 3, click on the sign in button. I click on the sign in button. The next step is click on sign in with IMDb. Okay, I click on sign in with IMDb. The next step is enter this email into the email field. I'm doing this. Step number 6, enter this password into the password field. I'm doing this. Step number 7 is click sign in. I click sign in. Now the expected result is the user is not able to log in the system, error message is displayed. This is exactly what is happening. I'm not able to log into the system with invalid credentials, so this test case is passing. I have the actual result. User is not able to log in the system, error message is displayed, which means that the test result passing, or just pass. So this is our test case. We are testing that we are not able to log in with invalid credentials. Another test case, for example, of course, can be user is able to log in with valid credentials, and you're going to have almost the same steps. You're going to open Google Chrome, go to imdb.com, click sign in button, click sign in with IMDb. After that, enter this email will be a valid email, so a real user. After that, enter a valid password for this user and click sign in. And the expected result will be that you are logged in with your email and your password. So you are into your user account. And the actual result, if you are logged into the system after that, then the test case is passing. If you are not able to log in with valid credentials, then the test case is failing. I hope that you get this, and now for homework to get better with test case, I want you to write this test case that I just talked about, that user is able to log in with valid credentials. Make this just like I did it here, step by step, with the test data, with the steps, and in the end you should be able to log in with valid credentials. This can be for another website, or doesn't matter. Just make sure that you have valid credentials and you can log in into a website. Make this, just practice writing test cases, and if you can make a test case like this into a notepad, trust me, it will be much easier for you later on when you're using systems like Jira to create your test case, and you'll have everything systematically put, and you just put the test steps, the result, the test result passing or failing. It will be much easier, but do this in the beginning. Make sure that you understand this, make sure that you can write it like this, and it will be much easier for you later on. Also, into the expected result, into the actual result, put screenshots. This will be much easier for the person who is executing the test case. Also, when you're writing bugs, you find a bug and you want to explain a bug to somebody, to a developer for example, put screenshots or even short videos explaining what is the test case or the bug about. It's much more easier for another person to know what are you talking about. Now, practice this, write a few test cases, write a test case that I told you about the logging functionality, that you can log in with valid credentials. Just practice this, you'll get better. Now let's continue with the next lesson. Hello everyone, in this video we are going to talk about what is black box testing. Black box testing, also known as behavior closed box specification based or eye-to-eye testing, is a software testing method that analyzes the functionality of a software or application without knowing much about the internal structure, design of that item, that is being tested, and compares the input value with the output value. The main focus in black box testing is the functionality of the system as a whole. So, to put this into simple words, black box testing is testing the functionality as a user. Just try to look at this like the test cases that we are writing. For example, you have an input field, and you know after this input field what should be the expected result or the output. But you don't know anything about the internal structure, about the code, the actual code behind the program. This is black box testing, when you're testing the functionality of a software, but you don't know anything about the code, the internal structure. So basically you're giving an input to the system, and you know what should be the expected output, and you verify the output. So this is how you determine if the test case is passing or failing, by the output, the actual result. But you don't know how things are working in the back. It's like a black box. That's why it's called black box testing, because you give it an input and you know what should expect in the end, without knowing what is actually happening in the back of the program. This is why it's called black box, because you only know what should be the actual result, but you don't know how things are working in behind. So black box testing is testing the functionality of a software like a user. So what is a white box testing? A white box testing also is known as clear testing, glass box testing, or structural testing. This is a testing technique which evaluates the code and the internal structure of a program. White box testing involves looking at the structure of the code. When you know the internal structure of a product, tests can be conducted to ensure that the internal operations performed according to the specifications and all internal components have been adequately exercised. To put this into simple words again, white box testing is testing the internal structure of a program. In the black box testing, you don't know what is happening behind the scenes. You don't know what is the program actually doing. In the white box testing, it's exactly the opposite. You know the code, you know what the program is doing, and you're testing exactly that. You're testing the internal structure of the program and you're testing if everything is working as expected. Basically, you're testing the code of the program. And by testing the code, you're testing a lot of things. You're testing the code coverage, the components testing, unit testing, and basically also security testing. So the difference between black box and white box testing is that in the black box testing you're testing the functionality. You have an input that you're putting as a test step, and you have an output, so actual result, but you don't know how things are working in the back. In the white box testing, you're testing the internal structure. So in the black box, you're testing the external structure. As a user, you're testing the functionality. In the white box testing, you're testing the inside of the program, the internal structure, and you're testing the code of the structure. This is the main difference between black box and white box testing. Now let's continue with the next lesson. Hello everyone and welcome to this lesson. In this lesson I'm going to talk about cross-browser testing and what is this and why you should know about it. So cross-browser testing is a process to test web applications across multiple browsers. It's logical, right? And cross-browser testing involves checking compatibility of your application across multiple web browsers and ensures that your web application works correctly across different web browsers. This sounds pretty simple, but this is something important that I want to talk about just for a few minutes just to let you know about this. Usually when you work in a project, when the client is giving his requirements, he is saying to which browser this application should work. For example, we are a company that our employees are using only Google Chrome, and we are using the latest version of Google Chrome, and this is the browser that we want to use for this application. Our requirements are only for Google Chrome. So that means that this application does not require testing with other browsers like Internet Explorer and Mozilla Firefox and Edge, for example, or Opera and Safari. This application have requirements This application have requirements to work only with Google Chrome. Another company, for example, can come and say, our employees are using Internet Explorer and also we are using Mac OS. We have Apple computers and we're using Safari. So we want this application to be working in Internet Explorer and Safari, and also we want to use our application on mobile. So this application have to be tested on Internet Explorer, on Safari, so on Mac OS, and also on mobile. You need to make sure that it's working as expected on your phone as well, because this is the requirements. And cross-browser testing is something that should be talked about in the beginning of the project when you're talking with the client about the requirements. And if they say they only need one browser, this is good for you as a QA engineer. But if they want this application to be working on 5 different browsers, you need to check every test case and every functionality that is working on multi-browsers platform, so on different browsers. Again, something that have to be discussed in the beginning with the client in the requirement phase, but just to let you know that sometimes you may need to test the same things into different browsers, into Firefox, into Chrome, into Internet Explorer, into Edge, Safari, Opera, and stuff like that, and mobile also. So now, after you know this, let's continue with the next lesson. Hello everyone, and welcome to this tutorial. Today we are going to talk about UAT, which stands for User Acceptance Testing. So what is user acceptance testing? User acceptance testing is the process of verifying that a created solution software works for the user. And this may sound really easy, but it's not that easy in the real world. And user acceptance tests consists of a set of test steps which verify if specific requirements are working for the user. So to put this into a simple words, I would say user acceptance testing is testing from a user point of view. You're logging into the application and you're testing like you would do if you were in your home and just trying to see if this site or application is working as expected. But this is not that simple, because there are a lot of things that should happen before the UAT. So as I told you in the beginning of this course, first the client comes and is placing his requirements. So client needs lead to his requirements, after that the implementation of the design, after that the coding, after that the unit testing, after that the integration testing, after that the system testing. This is our part as a QA engineers, we are testing the system. And at the end of this cycle is coming the acceptance testing, the UAT, user acceptance testing. And in order to get to this phase, this final phase, we need to make sure that everything is implemented as expected, everything is working as expected, all the requirements are met. We have been testing the system over and over again, and we are so sure that everything is working as it should be working, that we are giving the system to the client here, and we are saying, here you have your product, now you can test if everything is working as expected. And when the client is testing the application, this is basically the UAT, the user acceptance testing. He's coming and he's trying to break the system, he's just typing all kinds of things, and just things that real users would do when they're using the application. That's why it's called user acceptance testing, because the user is testing the application, the client is testing the application, but he's acting like an end user. And these are just steps executed in order to verify that everything is working as expected. Now let's continue with the next lesson. Hello everyone, and welcome to this tutorial. Today we are going to learn what is Jira. And Jira is a tool developed by Australian company Atlassian. It is used for bug tracking, issue tracking, and project management. The name Jira actually it is inherited from the Japanese word Gojira, which means Godzilla. And the basic use of this tool is to track issue and bugs related to your software. It is also used for project management. The Jira dashboard consists of many useful functions and features which make handling of issues easy. So, to explain it in my own words, because this is copied from the internet, Jira is just a tool where you can track the progress of your software, the progress of the product, and also a tool where you have all the documentation, all the requirements about the user stories, about the functionalities, and also tracking the progress and the bugs in the software. Basically, the whole project is in this system and you manage the project from there. And I have prepared some screenshots here to show you what exactly is Jira and how it looks like. This is a board, a typical board in Jira, and these columns here, you can modify them. You can have more than these 4 columns. Usually you will have to do, in progress, after that in development, after that in testing, in QA, and the final one is done. And the main concept here is that everybody have a task, and this one right here, for example, is a task in the column to do, so it's not implemented yet and it should be done. So a developer comes here and he doesn't have anything to do, he grabs a task from here and he moves the task into in progress. After he's ready, and when it's here, by the way, when it's in this column, everybody can see that this person is working on this task, and everybody's on the same page, so you know which colleagues are working on what and how much time they are going to spend on this. After that, you're taking the task from here and putting it into a testing column, or ready for testing, something like this. After that, when the tester, the QA, this is us, we are testing this task and we are moving the task into done. Usually the process is something like this, and you track the whole project here. Let me show you another screen like this, to do. After that you move it into progress. After that, awaiting QA. When the QA is taking the task and starting to test the functionality, we put the task here into this column in QA, and after that, done. This is a typical Scrum team Jira dashboard. And the last one that I want to show you is this one. This is the backlog. This is also in Jira, and this is basically, you can put your whole project here into the backlog. You put all the stories with all the documentation, all the requirements, all the acceptance criteria, and when you open a user story, which is basically a functionality, you can see all the tasks that are related to this user story. It's just a system to track your project with simple words. And you open this user story and you can see all the tasks related to this story. For example, there are 10 developer tasks, 5 QA tasks, 2 design tasks, and you can see also the test cases that are created. You're creating the test cases into the Jira. They are also linked into the story. You can think of this like it's like one document, and when you open the document you have everything linked, and it's really easy to track everything into this document. And this is basically how you manage the project. Let me show you the website of the Jira, and how they are showing here basically the same board that I showed you now. You can plan, track, release, report, everything in Jira basically. Here is a release board, which releases are in progress, which are not released, which are released yet, but you don't need to know anything about this yet. It's too early for you, for a junior QA. And you can see the task, open, in progress, the review, final approval, done. Basically you can modify these columns. Just remember that Jira is a development tool for tracking for tracking and managing your project. And the developers, the QAs, everybody is using this tool in order to be in line, to know your colleagues, to know what are your colleagues working on, how much time they are going to spend on something, if something is going to be ready for testing today, tomorrow. Basically, you're managing the project and everybody's on the same page. In this video, we are going to talk about regression testing. So, what is regression testing? Regression testing is defined as a type of software testing to confirm that a recent program or code change has not adversely affected existing features. Regression testing is nothing but a full or partial selection of already executed test cases which are re-executed to ensure existing functionalities work fine. This testing is done to make sure that new code changes should not have side effects on the existing functionalities. It ensures that the old code still works once the new code changes are done. Now, I will try to explain this with my own words and to make it a little bit more simple. So let's pretend that we have a program that is working fine, and developers are working on something new that they want to implement in the project, and they're developing this code for a certain amount of time, and the new functionality is ready. When the new functionality is being implemented to the already existing project, you want to make sure that the new functionality is working properly, and also everything before this functionality is still working properly. So basically, with regression testing, you're verifying that the old functionalities are still working after the new changes. Basically, that the new code didn't break the old functionalities. Regression testing is basically executing old test cases and doing old tests to verify that the old functionalities are working after you have made some changes in the project. And it's really useful when you have some automation here, because when you have automation tests and there is something new, a new functionality is being developed, you can run the automation tests and they are going to tell you if the old functionalities are still working, and this is going to be executed automatically. But you can never automate everything, the whole project, so manual testing is always necessary. I just wanted to let you know what is this regression testing, because you may hear this, you may be asked on interviews. You will know a lot more than this when you start working, when you get your feet wet and get into the field, into the IT field. But for now, just remember that regression testing is being executed to verify that old functionalities are working properly after the new code, the new functionalities are being implemented. So you want to make sure that the new functionalities are working, but they are not breaking the old program, and everything is working as expected. Hello everyone, in this video we are going to talk about exploratory testing. So what is exploratory testing? First, like always, I'm going to read something that I copied from the internet. This is like a general documentation of the exploratory testing if you search for it in Google, and after that I'm going to explain it in my own words. So, exploratory testing is all about discovery, investigation and learning. It emphasizes personal freedom and responsibility of the individual tester. It is defined as a type of testing where test cases are not created in advance, but testers check system on the fly. They may note down ideas about what to test before test execution. The focus of exploratory testing is more on testing as a thinking activity. Under scripted testing, You design test cases first and later proceed with test execution. On the contrary, exploratory testing is a simultaneous process of test design and test execution, all done at the same time. Scripted test execution is usually a non-thinking activity where testers execute the test steps and compare the actual results with the expected results. Such test execution activity can be automated and does not require many cognitive skills. Though the current trend in software testing is to push for automation, exploratory testing is a new way of thinking. Automation has its limits. So, to put it with my own perspective and my own words, exploratory testing is just trying to find bugs without having any scripts in mind. You just go into the system and try to break it. Just enter the software and try to do anything that comes up into your mind that you can test as a corner case. This consists of anything you can think of. Just go into the system and try anything you can think of to break this system. And I will give you an example with the imdb.com page. For example, if I want to test this login page, and I have already executed my test cases, and when you create test cases and execute them step by step, of course you think about them when you create the test case, but when you're executing the test case, you're just like your focus is limited exactly to the steps of the test case. So step 1 do this, step 2 do this, step 3 do this, and verify the result at the end. But sometimes, and I'm saying this from my own experience, I have found a lot of bugs when I'm doing exploratory testing. And by exploratory testing I mean I'm just going into the program and try to break it with anything that comes up into my mind. For example, if I want to test this login page without test cases, I want to do exploratory testing. First, I'm going to try writing something like this and some symbols like this, and to put some password and try to enter. I will try to put minus in front, and after that put some email to see if this is going to work. I will try to put only special characters to see what is going to happen. I will try to put for example a big kind of character, so I'm going to copy this, I'm going to paste this multiple times to see what is going to happen. Just trying to break the system with anything that comes to my mind. And this is called exploratory testing. Just trying to break the system and trying to test the system with anything that you can think of without having a script. And I have found a lot of bugs by doing this, because you don't have any framework that is limiting you, and you're just trying to do anything that comes into your mind, and sometimes by just clicking and everything and trying to break things, a lot of the times you're breaking things. And this is how you can find a lot of bugs, and trust me, sometimes this is helping a lot. Not everything has to be scripted. Of course you have to script and to make test cases, but exploratory testing is also very important. Now let's continue with the next lesson. Hello everyone, in this video I'm going to explain what is the difference between volume testing and load testing. So, volume testing is a type of software testing that is performed to test the performance or behavior of the system or application under the huge amount of data. Volume testing is also called fluid testing, and it is a type of performance testing. On the other hand, load testing is a type of software testing that is performed to test the performance or behavior of the system under the expected load of a real world. Load testing is also a type of performance testing. So they are both type of performance testing. So far so good. A little bit more about volume testing. Volume testing is a software testing performed to test the system under huge load data load. Data loss it is tested during volume testing. In volume testing, load is huge volume of data. Volume testing is used to measure the throughput of the system. Volume testing makes the system capable of real-world use. Volume testing saves maintenance cost, and volume testing checks system's response time. So, load testing. Load testing is a software testing performed to test the performance of the system under real life load. Data loss is not tested during load testing. In load testing, load is customers' expectations based. Load testing is used to measure the performance of the system. Load testing makes the system capable according to the end user. It doesn't save maintenance cost, and load testing check system's performance. And if you didn't understand any of this, I want to explain it just with one or two sentences with my own words. Try to remember it like this, because I know that it can be a little bit confusing, especially in the beginning, and a lot of people are missing what is the difference between the two things. So if you didn't understand anything from what I just read now, ignore all of this and remember it like this. Try to imagine that you are testing an upload functionality of a website. Your software is a website that have uploading functionality, and you are testing this. Volume testing will be testing this functionality with a huge file. So a file with increased size. Load testing will be testing the functionality with multiple small files. So volume testing is uploading one file, but huge file, and load testing is uploading many small files, for example 2000 small files. Again, volume testing is you're uploading one huge file and you're trying to see if the system is going to respond accordingly if you upload one huge file. So you're increasing the volume of the file. And load testing is uploading many small files. You're increasing the load. Basically, that's it. That's the difference between the volume and the load testing. I hope that makes sense and you understand it. I just want to mention this because when you go to the interview, you may be asked these kinds of questions. So try to remember it with the uploading example that I just gave you. Hello everyone, in this video I'm going to talk about automation and when should you move from manual to automation testing. And the answer to that is basically when you have tasks that you're repeating over and over again, then you want to think about automating these tasks and to avoid repetitive work. If you're doing one task 15 times per day and you're basically doing the same things and clicking the same buttons over and over again, maybe it's going to be smarter to automate this task and to run it automatically every single day and to forget about it in the future. But this is just the simple answer. The more comprehensive answer is that not everything can be automated. So is automation something really nice, really cool, something really necessary? Absolutely. Automation is the way to go, and automation is this is the future. Everything is getting automated basically, and this is definitely the future. You want to learn automation, But if you don't have any experience in testing and you're just starting out, do you want to learn automation from the beginning? Absolutely not. I think you should first start with manual testing, and you should learn the basics. You should learn the basics like reading the requirements from the client and knowing how the whole process, the software development life cycle is working. You should know how to write test cases, how to execute test cases. Basically, you have to be a really good manual QA or manual tester, and after that you can move on with automation. I think you should learn automation, but only after you have a really good foundation and understanding of the whole process. So automation is definitely something that you want to learn. It's really powerful tool to automate tasks and to have them running in the back, and you just check the results. But in the beginning you should definitely learn your basic testing skills, your manual skills, your understanding of the whole process, and only after that you should learn automation. And something very important is that automation cannot be done to every single task. You cannot automate everything. First of all, automation is have deadlines, and your client wants this functionality to be done and to be delivered to him as soon as possible, and you have a deadline and you don't have time to create automation tests, so you just manually test it. Try your best to do it as soon as possible, so you can release to production and the client is happy. If you have more time and you have somebody that can do automation tests, then you can start implementing Selenium UI automation tests, but they take a lot more time, and also not everything can be automated. So automation is the way to go, but first learn your basics, your foundation, and after that move on to automation. Hello everyone, and welcome to this lesson. I'm really excited that you're being here, because this is at the end of the course now, and you should be ready for applying to your first QA job. And this whole course have been preparing you for your first QA job. So the interview questions that I have prepared for you are basically everything that I taught you so far in this course. And I want to ask you these questions now and to answer them once again, because I want you to understand all of this and to have some kind of answers when you're going to your first job, when you're applying for your first job and you're into an interview. A lot of these questions, actually all of these questions, I have been asked when I first started applying for QA jobs. So I want to teach you how to handle an interview process, and how to make a good impression on somebody, and how to land a job as a manual QA engineer. So as I said, the whole course is basically a preparation for your first job, but let's do it once again in this video. So the first question that I have put here is, what do you know about the software development life cycle? And when they ask you this, you should say what I told you in the beginning of the course, that software development life cycle is a process for developing a software product, and the first phase is coming with requirements from the client. After that, when you have all the necessary requirements, is coming the design phase. The UA or UX designer is creating the designs for the client, and when the client approves these designs, then the implementation phase comes. This is the coding phase, and the developers are actually creating the product. After that, the QA engineers are testing the product, and if they approve the product, after that the software application is being deployed to production. That means that the client gets its product, and after that the Scrum team is maintaining the product, so something like supporting the product to the next 6 months. This is what a software development life cycle is. Next question is, what is a test case? Again, you should know all of these things. You can watch the previous sessions, but here I just want to answer with quick answers that this is how you're going to react and to answer these questions if you're on interview. So what is a test case? A test case is implementation of test steps, and when you execute them, you are verifying a certain functionality. Basically, test case is just a test steps that you're executing, and in the end of the test case, you verify that the functionality is working or not working as expected. What kind of testing do you know? Here you should say that there are two kinds of testing, functional and non-functional. The functional testing are related to the functions of the product, and non-functional is related to the performance of the product, just like I told you in the earlier sessions. And here you can also say all kinds of testing that you can think of. For example, unit testing, integration testing, stress testing, volume testing, load testing, regression testing, exploratory testing, all kinds of testing that you know. You can just say one or two words for them. You're really going to shine, and you're going to look really good if you say like 10 types of testing, and you can say one or two words about each one of them. And this is for junior QA, of course. You're going to shine. What is a bug? A bug is every single thing that is not working as expected. So basically you have requirements, you know how something should work, how this functionality should work. If there is something that is not working as expected, it's a bug. So everything that is not working as expected. What's the difference between white box and black box testing? With black box testing, you have an input and you're just verifying the expected result, but you don't know what is happening in the back of the program. So you're testing the functionality from a user point of view. In the white box testing, you're testing the internal side of the program. So basically you're testing the code, you're testing the security, and you know exactly what is happening behind the scenes. What is exploratory testing? Exploratory testing is trying to find defects into the system without having a script and test steps to execute. You're logging into the system and you're trying to break it with everything that comes into your mind. You're just exploring the system and trying to find defects. What is UAT and who is doing it? UAT stands for User Acceptance Testing, and this is done by the user. So after the implementing of the product, after verifying the product from the QA team, and after deploying the product, then the user, then the client, the final user, can do this user acceptance testing in order to verify that the product is working as expected. This is the final phase of the product development. What is cross-browser testing? Cross-browser testing is testing the application in different browsers in order to verify that the application is working as expected in different browsers. For example, Firefox, Safari, Chrome, Internet Explorer, and you can also say mobile application as well. What is the difference between volume and load testing? Here you can mention the example that I gave you earlier in this course with the upload functionality. So volume testing would be increasing the volume of the file, so one huge file with increased size, And load testing will be many small files uploaded to the system. For example, 2, 3, 4,000 files, but small files uploaded to the system. Can you automate every test case? No. Automation is something that have to be really carefully thought, and some test cases are just not applicable for automation. Automation is really powerful tool, but you should first do your manual testing. You should know how the application should work, and after that you can decide which test cases should be automated, but not every single test case should be automated. What is regression testing? Regression testing is verifying that old functionalities are still working as expected after uploading new functionalities. Basically verifying that the system, verifying that the new code is not breaking the old one. What is Jira used for? Jira is a project management tool and bug tracking tool, and it's used for manage your project and to create user stories and tasks, basically to manage the project and to track the progress of the team. What are you going to do if you find a major defect in the system you're testing? If I find a major defect in the system I'm testing, I'm going to report the bug immediately to the developers and to the project manager of the team, so everybody knows about this and the developers can start fixing the problem as soon as possible, and the project manager can do the documentation if something has to be done related to the client. And after I report immediately to the team, I'm going to create a bug report explaining everything about the bug, about the defect, how I found the defect. I'm going to attach screenshots. Basically, this question is a common sense, but I just wanted to answer it for you because this is something that I have been asked on the interview. And that's it. These are the questions that I believe are more than enough for you to start your first QA job, and I'm sure that you're going to do just fine. These are the foundations of the manual QA engineer, the junior manual QA engineer. This is a job that allows you to enter the IT field, and we all know that this field is really rewarding, and we have a lot of benefits, a lot of perks, good salary into this field, so you can become a just QA engineer and change your life and change your family's life. That's why I want to help you. I want to teach you all of this, because I was a few years ago, I was working something completely different, and the salary was not even near to the salary that I'm taking as a QA engineer. So I think everybody can learn these things, everybody can apply them, everybody can find a job and really change his life for a better. So I hope that you learned a lot from this, and I will see you in the next lesson. Congratulations for finishing my whole course. Thank you so much for being my student and for being here. I really appreciate you, and I hope that you get the value that you came here for and you learned a lot of new things. I'm sure that if you apply the things that you learned from this course, you can become a QA engineer and you can change your life for the better. Thank you one more time for being my student and for being here. And please give me a review for this course and tell me if I can improve something. I'm always improving on my courses, and I hope to see you in my next course.